a class homework assignment, I decided to build a proof of concept of cross-docket searching of PacerPro's database. For those of you not in litigation, cross-docket searching is interesting because it can help you quickly identify relevant precedent, like a sample motion for summary judgment filed in Southern District of Florida in front of a particular judge. First, let's take a look at the data source. For this project, I used Mode Analytics, which connects to PacerPro's backend, and started out with some simple SQL queries. For example, you can see here I was interested in things like case names, nature of suit, and docket entry information. I then joined these columns together and began to keyword search, looking, for example, for motions that might have been denied. In the end, I decided to pull back 2,500 random docket entries filed in cases before Judge James Donato back in 2015 and export that data to Excel. As you can see, the Pacer data is highly organized. Pacer is able to provide structured data because the courts require filers to select filing categories from a set of pre-existing approved event types. For example, you'll need to indicate whether you are in a contract or patent or fraud case, and whether or not you are filing a complaint or a motion, etc. However, we need to be careful with these tags, as some tags only apply to certain types of cases. We can see an example of this with the Hernandez case, a criminal matter that doesn't have a nature of suit. Our final web app will need to sensibly account for these distinctions to make sure valuable information isn't lost. For my next step, I transformed this data to JSON and then loaded it onto my seed file. My app will access the seed information through Sequelize, which is basically a JavaScript library that talks to databases. For now, however, let's switch to the front end and take a look at my homepage. Here, you can see I wanted the end user to know they were searching filings and cases before Donato from 2015. Knowing what you're searching for or searching across is important as it helps set user expectations. I also wanted them to have the ability to input a search query, which would filter their results. Let's see what that looks like. Looking at the text of the matched docket entries, you'll note I created hyperlinks to the corresponding case docket sheets. Doing so was pretty trivial engineering work, a single line of code actually. But the end user now has the ability to see the particular matched docket entry against the backdrop of the overall litigation, providing key context. Next, I wanted the end user to know what data set they were searching across. So I display this information on the cases page. As you'll remember, I pulled 2,500 docket entries. That corresponds to just 22 cases. Because the majority of results were civil matters, I enabled the end user to filter by nature of suit. This choice, however, means that the filter will not work for the Hernandez case discussed earlier. Here I enable an end user to upload additional data. Eventually, of course, we'd want to directly connect the app to PacerPro's database via an API, as, unlike this proof of concept, PacerPro has tens of millions of docket entries available for searching. Lastly, I wanted to create some improved filtering. For example, here you can enter multiple search terms, such as summary judgment, motion, and deny. This is where things start getting interesting. One question that often comes up is, how often is a particular motion type denied? In this first docket entry, we can start to see some of the potential problems with this type of query. For one, this shows motions for summary judgment that were both denied and granted. In order to handle this situation, we'll need much more sophisticated search filters. I'd also like to enable end users to tag particular entries themselves. So as a researcher, you're able to digest relevant information and then mark whether or not it meets your specific criteria before you download a final report. In any event, that's all for today. Thanks for watching.